Hi children, good morning all of you. Welcome to the online classes. This session is specifically dedicated in giving you a first-hand experience of how to solve the ISC board questions. It's not important that how I solve, you will get an idea what is the standard of the questions on a specific topic which we will be doing and how it comes and appears in the board examination paper. So today here I had said that ISC board questions on inverse trigonometric functions will be seeing it. Most of the questions I will try to solve as much as possible. So I hope you got this point clear and you understand. You might have done some questions, but might be some questions I can really help you out with a different method, an easier way to solve the questions. So definitely it's a very good eye opener for you all to understand, number one, the standard of the question which will come in the ISC board paper. Second is the approach to the questions, and third is the reasoning and how to present the question and solution in its proper format. So let us begin with this wonderful topic, the board questions. Here we go. That is nothing but inverse trigonometric functions. So children, let us see this part now clearly, what happens in this case. Before we proceed, I just want you to understand, you need to keep a formula based topic. It is actually, you know it. So what I want you to do is, you have to keep the formulas handy, at least for now, so that you don't waste time in investigating the formulas and getting the working done. So children, here we go. The first sum comes for a lecture now. Okay, 1 second. Right. If you look at this question here, it is given tan inverse. Solve the question. Now basically, what I want to share with you is, they had given solve the equation. So tan inverse x plus 2 plus tan inverse 2 minus x equals to tan inverse 2 by 3. So how I do that? Let us see. So tan inverse x plus 2 plus tan inverse. So what I am going to do is, I am going to try to work out with the solution tan inverse x plus tan inverse y. So if you remember the formula, just for first few sums, I will just get to the know-how of it. So tan inverse x plus tan inverse y is equal to, this will be tan inverse x plus y upon 1 minus xy. I think most of you are aware about this formula, right? Okay. So let us apply the formula now quickly and see how the things work. So tan inverse x plus y. So I will take 2 plus x also. You can take it instead of x plus 2, because 2 plus x and 2 might become easier for us to go for the kill. So this will become tan inverse x plus y, 2 plus x plus 2 minus x divided by 1 minus xy. So 2 plus x and 2 minus x is nothing but a plus b, a minus b, a square minus b square. So I put here 4 minus x square, that is nothing but a complete set. Now I do understand what I am trying to work out. I can cancel this x over here and I can open up this part and see what happens finally. So let us see this part. So this will become tan inverse. Try to understand, 2 plus 2 will become 4. It is just plain application of that formula here. Is 1 minus 4 is minus 3 and minus 3 minus x square. So minus 3. So x square minus 3. Do not forget this portion here. It is nothing but tan inverse 2 by 3. So I hope you got this. Minus of minus become plus here, 1 minus 4 minus 3, which is equal to. Now what is the idea? Remember the one thing, what I am trying to do is, I am trying to solve. Now when I say solve, that means in any particular inverse functions or equations, you need to find the value of x. Solve means find the value of x, or find the value of the variable which is put across in the equations. So here my objective is to find the value of x. So my thing becomes certain. I try to change both the things into the same inverse ratios. So by concept of equality here, I can say eventually 4 upon x square minus 3 is equal to 2 upon 3. You can simplify this as hard as easy possible. This will become 2. So, this will finally x square minus 3 is equal to 6, x square is equal to 9, and x is finally plus or minus 3. Now, one thing I always want to tell the children, I do understand many times you can find a solution that one number is acceptable, other is not acceptable. Sometimes both are acceptable. Sometimes, of course, when you have a different solution, you have no issue at all. But whenever you have two values, my personal suggestion is take these values and put in this and see whether it satisfies. So, if you look at this, plus 3 can be the solution definitely. If I put minus 3 here, so tan inverse is minus 1. So, minus 3 plus 2 is minus 1, and this will become 2 plus 3, 5. So, tan inverse minus 1 and tan inverse 5. I think if you apply this formula there, you will get the solution properly in the case as 2 upon 3. So, in this case, I feel the answer is both the values. Now, if you want to see, let us put minus 3 here. So, when x equals to minus 3, okay, verify. Okay, once I will show you. So, this will become tan inverse of minus 1, tan inverse minus 1, that is minus 3 plus 2 minus 1 plus tan inverse 2 minus x plus tan inverse 5. Why 5? Because 2 minus of minus 3 will become plus 3. 5 is equal to tan inverse 2 by 3. Now, I need to prove this. So, let us come to LHS now. So, basically what will happen, tan inverse of minus, I can write this, I can write as tan inverse 5 minus tan inverse 1, because tan inverse of minus will become this side, that is minus tan inverse 1. Now, I have tan inverse x minus tan inverse y is tan inverse x minus y upon 1 plus xy. So, what happens here eventually, this will become tan inverse 4 upon 6. You can also say this is nothing but tan inverse 2 by 3. That is what exactly is the RHS. So, when I put the second value x equals to minus 3 in this equation, is satisfied, and definitely it will be tan inverse 5, tan inverse minus 1, same thing. So, I think both the values are acceptable value for this particular inverse trigonometric equation. So, the value of x tends to be plus or minus 3. So, I hope you got this point clear. So, please watch it down. Okay guys, let us take the next question now. I hope you understood this question there. The next question is coming up for your lecture there. So, we are doing inverse trigonometric functions. So, the next question looks something different. Now, again in this case it is different than the previous question. Now, if you look at the previous question, it was solve. Solve, it means find the value of x in the given inverse trigonometric functions equations. Keep that in mind. Now, in this case it is given sin inverse root 3 by 2 plus 2 tan inverse 1 by root 3 is equal to 2 pi by 3. Now, here I want you to have a catch here. You have to prove. So, you have to prove either LHS equal to RHS or RHS equal to LHS, or both way you can simplify as you feel deemed fit. So, basically my working would be, generally I would focus on LHS here. So, LHS is nothing but, you can say, sin inverse root 3 upon 2 plus 2 tan inverse 1 upon root 3. Now, please understand what I am going to do in this case now. Pay attention now. So, either you change both of them into one single ratio, that is sin inverse or tan inverse, do whatever you feel right, and then you can apply. My suggestion and my experience says that getting into tan inverse would be preferred, not necessary. Okay, you can convert into sin inverse also this part and get the working. Tan inverse would be a better option most of the time. Okay, so let us see this part now clearly. So, before we proceed, I just want to remind you, I am talking about 2 tan inverse x. Now, this I can convert to sin inverse, I can convert to tan inverse. How? I will just share with you now. What I am going to do is, I am going to do the right angle triangle in this case. Okay. Now, in this is sin inverse ratio. So, basically sin inverse, there is no need to show this working, you can directly also write. So, sin ratio is nothing but opposite. So if I consider this as theta, so this is root 3, this is 2, this is 1 by Pythagoras theorem, right? So similarly here 2 tan inverse x, I can write in terms of tan inverse x. So 2 tan inverse x, I can write tan inverse 2x upon 1 minus x square. So basically these are the two formulas I am going to apply to convert this into tan inverse, this into tan inverse. 2 tan inverse x you can also convert into sin inverse. Now if you remember those formulas, 2 tan inverse x is tan inverse 2x upon 1 minus x square, right? Or sin inverse 2x upon 1 plus x square, or cos inverse 1 minus x square upon 1 plus x square. So basically what I am trying to do, understand, I am converting this into tan inverse by using the right angle triangle funda, and this by directly applying this formula. So let us see what happens now. So this will become tan inverse. Don't worry, tan is nothing but opposite upon adjacent. So root 3 upon adjacent, that is 1, plus now 2 tan inverse x. So sorry, 2 tan inverse x will become tan inverse 2x. So what happens now, this will become tan inverse 2 into x, x is 1 upon root 3, don't mix up, upon 1 minus x square, sorry, one minus x square. I mean to say what happens here is nothing but 1 minus x square. Now x is 1 upon root 3, so 1 upon 3. So now I begin my working there now. So how I get it, let us see. So this is nothing but tan inverse root 3 plus, now if I do the LCM here, 2 upon 3, 2 gets cancelled here. So 1 upon root 3 is left, 1 upon 3. So it is nothing but, sorry, I beg your pardon here, there is some error here in this case. Okay, this is nothing but tan inverse root 3. My job is over. Pi by 3. What is tan inverse root 3? Now, whose value is tan inverse root 3? I mean to say, whose value of what angle, or value of what angle is tan root 3? That is, tan of what angle is root 3? So tan inverse root 3 is nothing but, I think, pi by 3, right? So this is nothing but pi by 3 plus pi by 3 is nothing but 2 pi by 3, which is equal to RHS. You can have a look at this. RHS is 2 pi. So basically what I am trying to tell you, whenever you are proving, please understand, in solving what I did in the previous question, you converted both the sides into the same inverse ratios, and using the concept of equality you try to solve the sum. Similarly here, if I want to prove LHS convert into one single ratio, that is same ratio, tan inverse, or you can keep the sin inverse as it is, 2 tan inverse x, you know the formula of 2 tan inverse in terms of sin inverse 2x upon 1 minus 1 plus x square, right? So you can do that also and use the formula. So it's fine, jo jita wo sikandar iske andar. So keep that in mind. So pi by 3 plus pi by 3 I got to prove RHS. So that's the message that I give you. These are the main two categories of sum, which one of the type is 100% going to come in the board exam. So I don't want to lose it out. You can catch up and grab it for yourself. So please pause and note it down. Great. Next question. This was the first question we did. The second one and the third one. I know it's sum number 4 because the first one I missed actually. So we will take up that in the end. So sin inverse 4 by 5. So one again prove. Proving is nothing but sin inverse 4 by 5 plus cos inverse 2 by root 5 is equal to cos inverse 2 by 11. So best deal would be, now remember one thing, there are many things which you have to keep in mind. You can do anything you want, but basically remember cot inverse x is nothing but tan inverse 1 by x. Why? Because tan and cot is inverse of each other. So I can convert this into tan inverse. How? Drawing a right angle triangle, theta I am talking about. This is a separate one because the ratios are different there. So let us talk about the sine is opposite 4, 5. So this is nothing but Pythagoras theorem, that is 3. Similarly here it is 2 phi, it is adjacent upon hypotenuse, so I believe it is 1. So once you have the Pythagorean triplet, it's very easy to convert. So as I said, convert either to sine or cos to cos or tan to tan. But I said my preference will always be to convert it to tan because applying the formula of tan is more easier than with sine and cos. So let us get this now. So this I can write as tan inverse 4 upon 3 plus, I mean to say this plus. Now this is tan inverse, what happens? 1 upon 2. Now I have to solve this out properly now and see whether I get whatever the RHS they are asking us to prove. So tan inverse x plus tan inverse y. So tan inverse x plus, because we have the formula for only tan inverse plus tan inverse, I am not involving cot inverse here. So tan inverse x plus tan inverse y, you all know the formula, tan inverse x plus y upon 1 minus xy. I really want you to work, you can do this in the calculator quickly, but you need to really work out, because when you take pains, there will be always gains, right? So once it happens with this 4 upon 3, so what is the next part? I'll just work out. So just see what is happening. LCM is 6, so 2 4s are 8. 8 plus 3 is 11 upon 6 upon 6 minus 4, 2 upon 6. So this 6 gets eliminated, so 11 upon 2. So this is nothing but tan inverse 11 upon 2. Now what I understand from here, I have to prove in cot inverse. So tan is reverse of cot. So tan inverse x is cot inverse 1 by x. So this I can write as cot inverse 1 by x. So this I can finally write cot inverse 2 by 11, which is equal to RHS. Which is equal to RHS. So here the point is something very interesting, that is nothing but I just work out tan inverse x is cot inverse 1 by x is equal to cot inverse 2 by 11. I just reciprocate this 2, and that's the way this working is done. Yes, some might look simple, but remember, when you are giving the examination, it's a closed hall there, teachers are there, students are there, right? And that time your framework of your mind has to be a little bit full of confidence oriented. And even sometimes this simple sums also we tend to ignore, and how to go about it, what to do, and don't worry at all. Okay, you will get to know. Just keep your calm, patience, and explore your brilliant tendency, intelligence here, and I think explore your brilliant intelligence, and you would be through it. So I hope you got this point. Dear children, pause and note it down. Such a wonderful sum it is. It has come. So you understand the board pattern, how it comes up and how it appears. I hope you got this point, dear children. So please take it down. Hi children, let us take the next question now. The next question comes up. Oh, it's a good question. We can do many ways this sum. Compared to the previous proving sum, how this sum is different. Okay, how this sum is different. You, instead of a single inverse ratio or a pair of inverse ratio, you have tan inverse 1, tan inverse half, and tan inverse 1 by 3. So there is no pattern there. So what I suggest is, at a time you can convert or understand only one pair you can take up. I am talking about LHS now. So let me apply the formula and see what comes out. This 2 you can keep it up, or 2 can take it down also, there is no issue at all. So 2 as it is. So tan inverse 1 is tan inverse x plus tan inverse y. So tan inverse x plus tan inverse y, I am applying the formula to this now. So tan inverse x plus tan inverse y is tan inverse x plus y upon 1 minus xy, right, plus tan inverse 1 upon 3. Okay, great. So what happens now? This will become 2. This will become tan inverse 2 plus 1, 3 by 2, and 1 by 2. So 3 by 2, 1 by 2 is tan inverse 3 plus tan inverse 1 by 3. Now One more pattern of the question says, I can again apply tan inverse x plus tan inverse y and go further. Just now in the previous question, I shared with you tan inverse x is cot inverse 1 by x. Now, why I tend to tell you this? This is 3 and this is 1 by 3, reciprocal, right? Even though you don't do it, you stick to your basic formula of tan inverse x plus tan inverse y. Same formula you apply, which I applied in the previous step, you will get the same answer. But I will make my work a little bit simpler and easier for you to understand. Remember, there are important formula you have to always keep in mind. You remember this, tan inverse x plus cot inverse x is nothing but pi by 2. Remember, right? Similarly, sin inverse x plus cos inverse x is also pi by 2. Similarly, sec inverse x plus cosec inverse x is also pi by 2. So, you might say, what is happening? Why are you doing this? Because you know what I did, it was x and 1 upon x. So, I can change this to cot. So, this I can write as 2 tan inverse x plus tan inverse x I can write as cot inverse 1 by x. So, 1 upon 3 will become 3. Now, just see this pattern remains the same, tan inverse x plus cot inverse x, x is same element here. So, tan inverse x plus cot inverse x is nothing but pi by 2. So, 2 into pi by 2, cancel, what remains? Pi. That is what exactly they are asking us to prove, that it is equal to pi, and this is RHS. So, please understand, these are board questions. So, how? The sums are simple. In case some students don't remember this technique, you can apply tan inverse x plus tan inverse y to this. As it applied here, tan inverse x plus tan inverse y is tan inverse x plus y upon 1 minus y. Same formula you can apply to this step also. I challenge you, you will get the same answer. But anyway, be always wise and add to it some smartness. So, that is the point which I did over here. I understood 3 and 1 upon 3 are reciprocal, tan and cot is reciprocal. I just went for that formula and for that kill. So, in one single step we could conclude the second last step in this particular solution. So, I hope you got this point clear, children. So, this is a nice question. So, pause and note it down and enjoy, and always remember, you are attempting board questions. This should give you an idea of what is the standard, what is the pattern of the question which is put in the board paper. Please take it down. Next question. Oh, this question is prove that. Again prove. Of course, there is cot. Inside there is a problem. What is the problem inside? If you see carefully, it is pi by 4 minus 2 cot inverse 3. See, I have always seen a combination of inverse with inverse. I have not seen an angle and an inverse. So, best would be this portion I can convert into tan. This I can keep it as it is. I will see what to do with this later on. Pi by 4 I can say tan inverse 1, because tan of pi by 4 is 1. So, tan inverse 1 is pi by 4 minus, hold your breath, 2 as it is, cot inverse 3 I can say tan inverse 1 by 3, because you know there is no breakthrough in cot. There is no breakthrough in cot inverse ratio. So, best is I convert into tan inverse 1 by 3, because tan and cot are inverse of each other. And now I can apply. Now, this is not a problem. Here also there is no 2 tan inverse x. Everybody knows the formula 2 tan inverse x. Because there is tan inverse inside, I am not worried about the end outside part. I will see how to deal with that later on. Tan inverse x. So, convert this into tan inverse. So, 2 tan inverse x. Remember, you can write in terms of tan inverse also. I will just write the formula for your information. This is tan inverse 2x upon 1 minus x square is equal to sin inverse 2x upon 1 plus x square is equal to cos inverse 1 minus x square upon 1 plus x square. I hope it's fine. So, you can convert this 2 tan inverse x in any pattern of the solution. So, I want in terms of tan inverse. So, this what I can do is cot of tan inverse 1 plus 2 tan inverse x. So, tan inverse 2x upon 1 minus x square. 1 minus, don't say x square is 2 upon 3, x is 1 by 3, so 1 by 9. Right? The step doesn't work. If you have a calculator, you can quickly do it. So I will go ahead with this. I'll keep this cot as it is. I'll just simplify the inner portion first. Tan inverse 1 plus tan inverse. Now what happens? Let us see. 2 by 3, 8 by 9, so 3 by 4. You can simplify yourself. I did mentally. You can also, don't do mentally in the board exam. Try to write it out and solve it so that there is no mistake at your end. So tan inverse x plus tan inverse y, everybody knows what we do. Cot of tan inverse x plus tan inverse y is tan inverse x plus y upon 1 minus xy. Don't you think it is much better? Right? So what it comes up to, this will become cot of tan inverse, just see, 4 plus 3, 7 by 4 and 1 by 4, so tan inverse 7. But as you all know, cot and tan inverse doesn't go hand in hand because it is not compatible. Okay, keep that in mind. What I said, cot and tan inverse are not compatible. So inside, can you convert this tan into cot, because tan is reverse of cot. So this I can say cot of, okay, yeah. Okay, there is a small error there. I just want to rectify this. This you have to, this is a minus sign here. So this is a minus sign. I just messed up this. So this will become some error. Sometimes it happens. I have no issue. So this is nothing but 1 minus. So minus, and this is plus. So this will become 1 upon 7. 1 upon 7. So I hope you got this point clear. So now what happens, cot of, this will become cot inverse 7, because tan inverse 1 by x is cot inverse x, reverse of each other. So cot of cot inverse becomes compatible, and that is nothing but 7. That was exactly they are asking us to prove, that is complete set is equal to 7. I proved it is equal to 7, which is equal to RHS. Better is I always ask the children to conclude, therefore complete the sum and write it out, LHS equal to RHS, and prove it. That particular part you can copy it down in the end. Okay, it's up to you. But you do it preferably because you will have some time to ponder upon. So I hope you got this point clear, children. I'm sorry for that, because I just anticipated plus and we went into plus and plus and plus. But sometimes it happens. I am like you all, right? You are like me, so there is no issue at all. Okay, children, so let us take the next question now, which is waiting for us to work on. Again, show that, because as I said, if you see, look at the board pattern, most of the questions are happening in show that, but recently you will see they are asking more sums on solve. So anyway, as we go on, we have to look at both the aspects, both the pattern of the sum, and let us see how we go about that. So here, if you look at this, there is sine inverse 1 upon root 17 plus cos inverse 9 upon root 85 is equal to tan inverse 1 by 2, right? So how I go about that, let us see. So sine inverse 1 by root 17 plus cos inverse 9 by root 85 is equal to tan inverse half. Okay, let us see this portion now. So sine inverse x plus cos inverse. Now I told you, you can do anything you want working, it depends on you, right? So convert this, you can use the right angle triangle and work it out. This also you can use the right angle triangle. There are different Pythagorean triplet. I am talking about theta here. Sine is opposite upon hypotenuse 1 root 17. This will become 4, right? And cos is adjacent 9. This is root 85. So I think this will become 2. Right. Okay, guys. I want to convert into tan. So this will become tan inverse opposite upon adjacent 1 upon 4 plus tan inverse 2 upon 9, as simple as working with this. Now everybody knows tan inverse x plus tan inverse y. What is tan inverse x plus tan inverse y? It is nothing but tan inverse x plus y x plus y upon 1 minus xy. I hope you got this point clear. So, what happens here, this is nothing but tan inverse, we can solve this out. Okay, I will solve this. 4 9s are 36, 9 plus 8, 17 upon 36 upon, this is 36 minus 2, 34 upon 36. This gets eliminated, 17 1s are, 17 2s are, so that is nothing but tan inverse 1 by 2. Let us look what we have to prove, which is nothing but RHS. So, that is the pattern of the question. The sum might look difficult here, but we go with tan inverse ratio become easier. I again tell you, even though you keep both the things, this sine inverse, you can convert this into sine inverse, still it is fine, no problem at all. Okay, but only the calculation becomes little bit lethargic in nature. So, my suggestion, my advice is convert into tan inverse. I do not say 100% sum, but many of the sums you can approach this method become easier for us to solve it and simplify even without using the calculator. Okay, so pause and note it down. Okay guys, let us take the next question now. 2 tan inverse 1 upon 3 plus cot inverse 4 equal to tan inverse 16 by 13. So, let us have a working on this. 2 tan inverse 1 by 3 plus cot inverse 4 is equal to tan inverse 16 by 13. Now, once again I think I have to prove tan inverse, so I can convert this to tan inverse. So, this will become tan inverse 2x upon 1 minus x square plus tan inverse 1 by 4. I am talking actually LHS. Okay. Now, let us see what happens here. So, this will be tan inverse 2 upon 3, sorry, there is a big 3 there. So, I will just work out, that is tan inverse 2 upon 3. Okay, upon 1 minus 1 by 9 is 8 by 9 plus tan inverse 1 by 4. So, I think 2 4s are 8, 3 3s are 3 by 4. So, this will be tan inverse 3 by 4 plus tan inverse 1 by 4. So, what you say, what you feel is this, I try to pretend that I have to work out with tan inverse x plus tan inverse y. So, I can do it further now. So, tan inverse x plus tan inverse y, I showed you what you have in yourself. So, this will become tan inverse x plus y upon 1 minus xy. Oh, that is a big change there. So, let us see what happens. So, it will become 4 upon 4 is 1. So, this is tan inverse, just 16 minus 3, 16 minus 3 is 13 and 16 will go up over there. So, it is nothing but 16 upon 13. Do not you see the same thing here? That is the point. So, it is not difficult, you have to just keep your guards, okay? Keep your guard and work on the sums, because it becomes always easier to attempt it and try to work out this particular pattern. So I didn't do anything, I just stick to the basic sums what I did. And remember, these are board questions again and again. When you're attempting this question, I want to remind you that these are the board questions, and really you can hit the nail on the head, or it's reverse. Head you don't hit on the nail, nail on the head. I hope you got this point. Okay, so pause and note it down. Okay guys, the next question says solve. So after a long time we have come to solve now. Okay, remember this is the part of solve for x, that means find the value of x. So the sum is only this much portion, tan inverse x minus 1 plus tan inverse x is equal to tan inverse, no sure, whatever it is. Now solve, it means you don't have to prove LHS equal to RHS. So both the equations is already valid. So you can adjust anything, you take this side, so best would be, what I can do is, I can just write this to my convenience, x minus 1 plus tan inverse x plus 1 is equal to tan inverse 3x. I take this tan inverse x this side, tan inverse x this side. Now I do, you might say why you choose this, because see here when I do x plus y, this minus 1 plus 1 will get cancelled, that can make my work, the simplification part becomes more simpler. So how I go about that, let us see. So I think as it is given completely the equation, this x, remember this is a part of solve for x it is, so remember it is not part of the sum, always keep that in mind. So what I can do, both simultaneously I can bring down the working. So tan inverse x plus tan inverse y is tan inverse x plus y upon 1 minus a minus b, a plus b, x square minus 1, that is tan inverse x plus y upon 1 minus xy. I am just doing basic mathematics, you can just judge for yourself. Tan inverse 3x, a tan inverse x minus tan inverse y is tan inverse 3x minus x upon 1 minus xy. Now as I said before also, both the sides when it happens to be solved, both the sides convert into the same ratio so that you can equate the integral part. But before equating the integral part, what am I supposed to do? I can eliminate this part very clearly, right? And I think I can simplify whatever is come up. So I can just work out one more step. This I can write 2x. Now see what is happening. 1 minus of minus 1 is plus 1. So 1 plus 1 is 2. Minus x square is equal to, this will become tan inverse 2x upon 1 minus 3x square. So as it is, don't cancel this tan inverse, equating you can get 2x upon 2 minus x square is equal to 2x upon 1 minus 3x square. So what happens, children? So I think I can eliminate this part, 2x gets cancelled, and if I simplify it further, this will become 1 minus 3x square is equal to 2 minus x square. So 2x square is equal to 1. Now x square is equal to 1 by 2 and x is equal to plus or minus 1 by root 2. I really have a doubt. I want to share with you something very important. If you remember the first question of solving which you did, first or second question, I remember that, you had two values of x. So you have to select the exact value. Okay, might be both the values are valid or one value is valid. So plus 1 upon root 2, apply the formula and see what satisfies. Okay, so I just leave it on you all and try to tell me what is the answer. I give you 1 minute time, just take plus 1 upon root 2 minus 1, 1 upon root 2 plus 1. Now just put the values there and see what you are getting it. So try it out properly. In fact, here also you can put directly, because this is just a simplified, oh this is not, sorry, this here you have to put actually in the sum directly, as that is a better option, right? Try it out, whether both the values are accepted, only one value. Catch which happens to be there in some questions, both the values are satisfying, no doubt about it. If sometimes it happens. If it cross multiply, it becomes cubic polynomial. So let us see one working. I am purposely showing this because I don't want you to miss. Okay, so that's the point. I keep there, don't cancel it out, because 2x, it is 2x. Okay, so I just take this side, 2x number I can cancel. So x upon 2 minus x square. I take this x upon my 1 minus on this side. So minus x upon 1 minus 3x square is equal to 0. Now what happens, let me tell you, if I take x common, this will be 1 upon 2 minus x square minus 1 upon 1 minus 3x square is equal to 0. This is exactly the working which you got, 1 upon 2 minus x square, 1 upon 1 minus 3x square. And what is the answer for this solution you got? In this case, you got x equals to plus or minus 1 by root 2, and this x is also equal to 0. So other value is also there. Now this is the pattern of the question there, because it is tan inverse minus 1 plus tan inverse 0 is 0, tan inverse 0. So tan inverse, I think this should, it is, try to understand tan inverse, this is minus 1, that is minus pi by 4, leave it as it is. This is tan inverse 0 is 0, this is tan inverse 1 minus pi by 4 minus pi by 4 plus pi by 4 is 0, right, and here it is 0. So that means 0 also satisfies. So this I will want to remember. So I have to add one more solution there, x equals to 0. Okay, keep that in mind. You have to do this pattern. The third answer also is valid. Keep that in mind. Okay, so that's the pattern of the working. I might have cut here, actually cut 2. I take this side, I showed the working that side, and this portion, the working happens to be plus or minus 1 upon root 2. But I can't ignore, because if you cross multiply, it becomes cubic polynomial. Cubic means 3 roots. And if I say and find that 0 also satisfies this equation. So I mean to say that 0 also is a solution for this particular question. So I hope you got this point clear. Children, I think most of you must have got this. If in case you miss out this part, so might be you lose half mark or 1 mark based on the total weightage for this particular question. Okay children, so pause and note it down, and this working I want you to keep in mind. Okay, or you can take it down. 30 seconds I give you for this. Quickly do it. Okay, now this question is something very close to my heart. What is given to you here? Okay, this is given. Okay, and they are asking you to prove something else. Now I think here this sum is completely different than the solving part and the proving part. In this case, they had given equation in terms of inverse ratios, and they are asking us to prove completely in terms of plain variable format. There is no inverse things existing over here, right? So let us believe this what I can do over here and see how I work it out. Okay, so first thing, this is what given. So any given information is that you have to use that given information to reach the unknown thing. So let us see this part. So first thing is, what I can do is I can try to apply the formula for this. But understand, this sin inverse x plus sin inverse y is nothing but sin inverse x root 1 minus y square plus y root 1 minus x square. It's a huge formula, and then pairing up with z is slightly different. As I said in the previous question, anything completely given to you can manipulate by shifting here and there. So what I can do, check it yourself and think. हाँ, गुड आफ्टरनून अशोक, बोलना। क्या हाल है? हाँ, एकदम फिट है, कुछ नहीं अभी। हाँ, अच्छा, हाँ, कल के प्रैक्टिस कल, ओ, परसों क्या है? केम? सैटरडे तो नहीं है, बट एज मंडे केमिस्ट्री। हाँ 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 हाँ, ओके, तो पूरा सेटअप करने के लिए आएगा वापस पर। सारा निपटा के निकल जा पहला। लफड़ा है, डर लगता है क्या?
चलो जिंदगी क्या भी इतना डर के नहीं।
वो भी बराबर है, वो भी बराबर है।
कितने दिन तक ये करते रहेंगे ना हम सब। अभी कल देखो वैक्सीनेशन के लिए घर रह गया और वैक्सीनेशन नहीं हुआ।
अरे बाप रे। हाँ ना, 3 मंथ्स के बाद ही ले सकते बोला ना।
नहीं तो क्या पागलपन है सर, पर वो वैक्सीन है ना
हम्म।
जो सॉकेट का है भारत फोर्स वाला,
वो बेस्ट है।
उनको दे रहे हैं
हो,
सेकंड डोज।
क्या बात कर रहा है?
अरे सर मैंने कल ये किया ना, उनको सेकंड डोज दे रहे हैं, बस कोविशील्ड जिसने लिया है उनको
हम्म।
नहीं दे रहे।
अच्छा 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 अच्छा।
अभी क्या प्रॉब्लम है समझ में नहीं आ रहा है, मतलब ये डिफरेंस क्यों, इनके पास वैक्सीनेशन नहीं, इसके
हाँ
पास
सर, यही पॉलिटिक्स है, बाकी कुछ नहीं है।
कुछ फायदा नहीं सर, कुछ फायदा नहीं।
बेकार है कहो
जो
बात।
पहला पहला लेके रखा है ना
हम्म।
वो उसका यूज नहीं है।
हाँ ना।
नहीं तो क्या पागलपन ये सब सर।
चलेगा चलेगा। और क्या बोल रहे सर, सब ठीक है?
बाकी सब ठीक है सर।
ठीक है, चलेगा, चल। हाँ, चल मैं कैचअप करता है तेरे को थोड़ी देर से।
ओके
हाँ चल।
ओके
ओके बाय। हेलो। क्या हो गया, खाना वगैरह हो गया? हाँ 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 हाँ, नहीं नहीं, अरे हो जाता है, ठीक है। तो मैं एक नया फ़ोन लेके दूँ क्या मैं? सैमसंग है, सैमसंग वाला अच्छा है ना मैम? वही चलता है, अच्छा। अच्छा, listen, he came to take the signature. He came to take the signature, okay? So I put the ball in his court only. I said, sir, I'm signing it, okay? You confirm because Michelle Bhutia is approved. बोला सर आपका नाम, बोला मिशेल बूटिया इज अप्रूव्ड फॉर दिस practicals. I said नहीं क्या, मतलब वाइवा, and because she is COVID and all, she could not come. So you decide and you put whatever name you want. You talk to the headmaster. So I left the name blank and I signed over there for बोल के, बरोबर क्या ना? तो वॉट एवर दे आर डूइंग लेट देम डू ना, लेकिन वाई आई शुड राइट द नेम? तो बोला हाँ सर, मैं हेडमास्टर को पूछ के किसका भी नाम डाल, मैं किसका भी नाम डाल, बट ध्यान में रहे कि मिचेल वॉज सपोज टू कम बट शी बिकॉज ऑफ कोविड शी कुड नॉट कम, नहीं कैसा? तो दे विल डिसाइड एंड लेट देम पुट वॉट एवर नेम यू वॉन्ट। हाँ आई सर इट इज़ फॉर योर रिकॉर्ड ओनली, नहीं क्या? हाँ सर वो कुछ नहीं, चलेगा। हाँ करेक्ट बोला ना, करेक्ट किया ना? आई जस्ट पुट द बॉल इन द कोड ओनली, नहीं क्या? चलो ओके, दैट ओनली आई वांट टू अपडेट यू। अच्छा मैम लिसन ना, आई नो यू आर वेरी बिजी, ओके? लिसन ना, आई नो यू आर वेरी बिजी. What I will do is only 5 minutes, not now, you will get a link 5 minutes के लिए on YouTube. So it will be a live lecture, only 5 minutes, only one sum, okay? So I will tell you before that. It will come in next half an hour time, it will happen. Okay, you are free but 5 minutes? चलेगा. So I will send you a link and then I will call you. Okay? In 5 minutes you can click the link, then the lecture will live start. So how the live lecture happens, I just want to know from you. Okay, thank you bossy. Bye. अरे नहीं, no problem, I know that. Yeah, ठीक है. Yeah. Well guys, let us see the next question which is coming up. Sine inverse x plus sine inverse y plus sine inverse z is equal to pi. From the given information you have to go the unknown. So as I said that if you are going to take this sine inverse z better, because this is given, you can manipulate anything anywhere. So what I am trying to do is I am going to work out like this. See, sine inverse x plus sine inverse y is equal to pi minus, I think by work becomes a little bit lighter, right? Okay, now how I do about it? Now sine inverse x plus sine inverse y, if you see what happens now, sine inverse x plus sine inverse y, I can say this is nothing but sine inverse x root 1 minus y square plus y root 1 minus x square is equal to pi minus of sine inverse z. I want to remind you, remember any inverse ratio is an angle, so it is pi minus theta. Can I take the sine inverse this side? Yes, I can take it. So what happens now? X root of 1 minus y square plus y root 1 minus x square. Look at this, is equal to, sine goes this side there, understanding or not? This is nothing but sine of 180 minus theta. So sine of 180 minus sine theta. So which is eventually x root of 1 minus y square plus y root 1 minus x square. Sine of 180 minus theta is sine theta. So sine of sine inverse z will become z. So you look, there is no inverse ratio. I came to a situation there is no inverse ratio. Now only basic mathematics is calling up. You can square both the sides, but what will happen if you square both the sides? It will be a square root goes, b square goes, plus 2ab will be root of 1 square, 1, you can do that, but again you have to keep squaring. So best is I shift this side, x root 1 minus y square, because there is root of 1 minus, there is no root of 1 minus, so I just kept it as it is equal to z minus y root of 1 minus x square. Now I can square both the sides, simple working, that's it, my job is over. So this will become x square 1 minus y square is equal to, what will happen? Z square minus 2zy, a minus b whole square is a square minus 2ab 1 minus x square plus y square 1 minus x square, b square. So a square minus 2ab plus b square, apply the identity formula. Once you finish with this, I think my job is over. I can open this up. This will become x square minus x square y square is equal to z square minus 2yz root of 1 minus x square, open this up, plus y square minus x square y square. So just see now, I cancel this out, minus x square y square minus x square y square cancels. My job is over, because that's what they are asking. Take everything on this side. So this will be x square minus y square minus z square plus 2yz root of 1 minus x square is equal to 0. Wow. I got the exact proof here. Right. So there is no pattern, which is what they are asking us to prove. It's not LHS equal to RHS. This is given to you, so I am manipulated by shifting. So that's the first and most important method of sum which is happening. So I hope you got this point clear, children. So pause and note it down. I would just mark star. This has come twice in the board exam. I mean, it is not in the same paper, but I don't know the years, but definitely in recent times it has come. Okay, so please note it down.